So in this video, what I'm going to talk about is how to make compounds with what we call polyatomic ions, and how to also name them. So we sometimes call these ternary compounds because you're going to see three different element symbols when you're looking at these compounds. And these polyatomic ions can be found on your ion table. Okay, so these on the right-hand side are what we call the polyatomic ions that you're going to be using for this naming process. Well, what is a polyatomic ion? Well, it's a group of atoms that behave as a unit, so they are one particular thing. So overall, when you look at NO2 minus, that means the nitrogen 2 oxygens have an overall -1 charge. So they behave as a -1. So polyatomic ions are all negatively charged. So if you look at your list, they are all negatives on the right. The only one that is positive is something called ammonium, NH4+. Now, how they behave is they behave like one thing. So if we were doing this in school, what you would see is the following. So let's take two different ions here. Okay, so let's say it's copper 2+, okay, copper 2+, and then PO43 minus. So since this has a +2 and this is a -3, we can't just put the pieces together and make it 0. So with these polyatomic ions, they are going to behave the same way as negative ions are going to be, meaning however many negatives they are, you need to have as many positives. So if I was trying to put together copper 2+ and PO43 minus, I would actually have to have 2 of the PO43 minus, and I would need to have 3 of the copper 2+ to get it exactly to 0. So if we think of it as, again, puzzle pieces, okay, and the fact that the PO43 minus is all one thing, you put it together in such a way so that you have 3 of the 2 pluses and you have 2 of the 3 minuses. So it doesn't matter what the actual symbols are. What you need to pay attention to is the charges, okay? So what I'm about to teach you has no difference in what we did with the binaries. This just has more stuff to look at. So making compounds with polyatomics are same, okay? Charges have to equal 0. The only difference with this is I have to use parentheses if I have multiple polyatomics. So if I go back to this example here, okay, I have 3 CUs. So I have to write 3 on the bottom here to say I have 3 of those, and I have 2 of the PO4s. So when I write the PO4, I have to put it in a parentheses and put a 2 on the outside. So what I jokingly say all the time is I have to hug my polyatomics with the parentheses. So if I have 2 of the PO4s, I need to put parentheses around them. I cannot change the PO4 to say 6 and call it PO6. That doesn't work. You can't call it you can't multiply by 2 and call this P2O8. Can't do that. So you're gonna hug your polyatomics with parentheses and write how many you have. So let me go through a couple examples here so that you could see what I mean. And as I do them, please pause the video as you are doing them. So sodium and NO3 minus is called nitrate. Nitrate, again, from your list, you're always referring to your list. So if this is a +1 and a -1, I just write it as NaNO3, okay? I have 1 Na and 1 NO3. Now I don't need the parentheses because I only have 1 of the NO3s. Na plus and SO4 2 minus. So this is a +1, this is a -2. So I can't put them together 1 to 1. That will not get me to 0. So how many NAs do I need? I need 2 of them. I need two +1s and a -2. So I need to write Na2SO4. So this is where you might have multiple polyatomics. So magnesium is +2, OH minus is a -1. So I need 2 of the negative ones in order to get this to 0. So I'm going to write magnesium OH, but OH is a polyatomic. So I have to put parentheses around. I have to hug my polyatomics and put a 2 on the outside to say I have 2 of those. Now this one, out of all of the polyatomics, it is very easy for you guys to write a 2 on the outside. Somehow the OH in your head just doesn't stick as a polyatomic. By the way, if you write this, you're essentially writing water there, and that's not really what the reaction is. So I always show that to you so that you don't make that mistake with OH. So this is ammonium. Okay, this is the only positive polyatomic we have, and this is my -3. So I have a +1 and a -3. So I need 3 of the +1s. So I have to put NH4, I have to hug my polyatomic and put a 3 on the outside, and then put PO4 on the out. Okay. Now, in terms of naming, the cool thing is, all you got to do is name what you see. So if I see NO3, it's going to be called nitrate. So I call this sodium nitrate. So what about this one, Na2SO4? Well, SO4 on your list is called sulfate. So again, it's just going to take some practice with you getting used to what is everything's name. So I'm going to pause the video and then write the names of the next 2. So this is called magnesium hydroxide, and this is called ammonium phosphate. So the only thing you need to kind of add to this is, if I have a polyatomic and I have a Roman numeral naming ion, so that's going to be, again, these metals, okay, on this chart here. If they have multiple names, excuse me, yeah, multiple charges, they're going to have multiple names. So you're going to name the cation and then the polyatomic name, but you need to include the Roman numerals for anything that is in the middle, called transition metals. So here I have CuNO3 and CuNO3, or CuNO3 2, CuNO3. So this is where you are going to have to need to use this table a lot. So NO3 is nitrate, and it is a -1. So I'm going to write NO3 minus for each one of these. Now, in this case, I only have one NO3, so the copper, in order to make this 0, must be the +1 variety. And since I have 2 negatives, okay, I got 2 on the outside of the parentheses, that means I have 2 negatives, this has to be a +2. So copper must be the +2 in the first example. So this is copper nitrate, both of them are, but since both of them have a different charge, I need to put in parentheses what that charge is. So this is Roman numeral 1 because it is a +1 charge, okay? And then this is Roman numeral 2 because this is a +2 copper, okay? It has nothing to do with how many you have in the formula. So it doesn't, both of these only had 1 copper in it, but it has to do with, again, the charge. So see if you can write the names of these 2. I'm going to pause the video and show you the answer. So again, this is iron 2 phosphate because I have 3 times the +2. I have a 2 times the -3. So that's the only way I could get to 0. So this has to be a +2. This of course, phosphate is a -3. So this is iron 2 phosphate. And then since this is 1 to 1, I know phosphate is a -3. So iron must be the +3. So this is iron 3 phosphate. Again, it has nothing to do with how many irons you have in the formula. It has to do with the charge.